libuv overview. Let's talk about this beautiful library that Node uses for all asynchronous I/O, you guys. So the libuv is an I/O library that sits behind Node.js, and it does the event loop, it does the polling, it does the network operation, it does the file operation, it does the DNS operation, it does all of these stuff. And it also has the threads that Node uses in order to allow for non-blocking operations, because without them, it's not entirely possible to do non-blocking operations. And the most important thing is the cross-platform, because it's written in C. So they wrote it such that it's cross-platform. And not only just running, but actually it's designed to run on different kernels. Because you see, every kernel does networking differently. The BSD, which is what Mac is built on top of, is different than Linux, is different than Windows. And so they built this library that works with any operating system. And then they set on top of it as Node, right? Because that's the most difficult thing in Node is the I/O. How can you do a file read and a network read and dealing with sockets and networks without actually having to understand what's behind the scenes? How can you make it compatible? Because every kernel does things differently, and those guys nailed it. They built a library that works on all of them. That's why it's popular. You don't have to use it for Node. You can use it for other things, right? Especially if you want your program to run on multiple operating systems. You need to nail I/O. So here's the components of libuv. You have the network piece. That's TCP, UDP, TTY, which stands for teletype writer, I think. And this is basically anything less to deal with screens. If you want to read from the input, it's DDIO, and you write to the screen, text-based terminals, right? Pipes, like Unix pipes, how to talk between two different processes using pipes, and of course other different examples as well. And there is this big interface that's called UVIOT, which sits on top of anything Linux. This is Linux EPOL. If you're using Linux, we're going to use EPOL. If you're using BSD or Mac, we're going to use this. And event port, I think, is for Solaris, if I'm not mistaken. So we have the KQ as well, EPOL for Linux, and this is what basically we're really interested in. And then we have the file I/O. File I/Os are not asynchronous by default, but libuv, they made it asynchronous. How? They use the thread pool to allow that, right? So when you do a read file, a thread out of a certain number of thread is being used to perform the read I/O. Same thing with the DNS. A thread is being used to perform the thread I/O. That's why you gotta be careful. If you're doing a lot of file I/Os, you might starve your DNS. And if you're doing a lot of DNS, you might starve your file I/O. Why? Because you only have limited number of threads. And this, we're gonna talk about how we can configure this to change it based on number of cores. But this is one key understanding that you need to have in order to basically build better applications. And user code, of course, some user modules can directly reference the thread pool, as we're gonna see in the end of this section. Here's the interesting loop for the libuv. It looks identical, if you remember. This is the initialization loop. The initial phase comes right here. Then we have timers. Then there's like a loop. Is the loop alive? Yes. Call pending callback. Run idle handling. Run prepare. So these guys are merged into one phase in node. but they are 2 in libuv. Then we have poll for IO. Then we have check handles, which is the what is it called? The set immediate. Then we have the close. Then we have update loop timers, and then run do timers. So there's like these guys are kind of this, and it seems like these two. This is the timer one. This is the update loop time. So there's another phase that just updates the loop time. But if you notice, it's like almost identical, right, to the node phase, but it's just like simpler. So libuv thread pool. Let's talk about the thread pool. It's a pool of thread dedicated for certain tasks. Right? What are the certain tasks? Kind of talked about them a little bit. This is the environment variable that you can set to actually change that thing. And you can set the default is 4, and you can change it. It's only used currently by file IO async. As we talked about it, we're going to spin a thread. What's spinning? We're going to use a thread. We're going to block on this particular thread. We never read on the main thing. Unless you're using file read sync, then you're going to block the main thread. DNS and user code are also being used with a thread pool. And you can change this. Of course, you cannot just change it to any number, right? It has to make sense. The good number is just to match whatever the number of cores you have, the logical cores. But that also can be increased if you have if you are mainly IO driven, right? Not CPU bound. Network IO, we kind of talked about this, right? We do a ePOL for Linux, KQ for BSD Mac, event port for Solaris, and IOCMP for Windows. And all of this is just abstracted away by this beautiful interface. So yeah, you can do all network IOs with libuv. That's why Node.js is so popular. File IO, right? Files cannot be done synchronously at all. Well, the exception is IOURINC. IOURINC can dedicate it to a kernel thread which does the actual reading, right? But mostly when you read, you're blocking. When you call system call read, that's a blocking read, right? So we have we read on a thread, we block the thread, we talked about that, and then keeps the main thread unblocked. That's what we want. We want to keep the main thread as unblocked as possible. And this is what simulates asynchronicity. Summary. That's the end of this very brief overview of libuv, right? We'll just talk about some theory and then we're going to jump into the practical. So yeah, Node uses libuv for IO loops, asynchronous IO, and file and network. We're going to do some more stuff. Next, we're going to talk about asynchronous IO. Stay tuned.